Now, exponential function. Exponential function. When an unknown is the index or power of a function, that is number, then it is an exponential function. What do we say as an exponential function? Exponential function is when an unknown becomes the power. We call it exponential function. Example, 3 raised to power x equals to 9. This is an exponential function. Such equation can only be solved if both sides can be expressed in the same base. Okay, so they have to make sure that this kind of base, both sides, their base have to be the same. We have example here. We have evaluate 2 raised to power x equals to 16. Okay, 2 raised to power s equals to 16. If you want to evaluate this, let's take it one after the other. Under this example, 2 raised to power x equals to 16 is the same thing as 2 raised to power s equals to 2 raised to power 4. 2 raised to power 4 will give you 16. 2 times 2 times 2 times 2 is 16. 2 raised to power 4 doesn't mean 2 times 4. It means 2 times 2 times 2 times 2, which will give you 16. Alright, so therefore the base is the same. If the base is the same, the base can cancel itself. So 2 cancel 2, you have that x will be equals to 4. Then 3 raised to power, the second example, 3 raised to power 2x equals to 27. Alright, so 3 raised to power 2s is equals to 3 raised to power 3 will give you 27. That is 3 times 3 times 3 will be 27. So you see the base is now equal in both right hand side and the left hand side. So 3 will cancel 3. You discover that 2x will be equals to this power of which is 3. So 2s equals to 3. So we are looking for x, which is the unknown. Divide both sides by the coefficient of x. The coefficient of s here is 2. So therefore x is going to be equals to 3 over 2, which is what we have here. Also, we have x raised to power 1 over 3 equals to 3. Alright, so if you look at this very well, you can take the cube of both sides. Introduce a cube. What happened to right hand side can happen to left hand side. So here we put 3 and then we put the power of 3. We put the power of 3 here. Alright, so why is it so? So that this 3 multiplied by this fraction, this fraction is a power, this 3 is a power, they can multiply themselves. By the time they multiply this fraction, this 3 can cancel this 3. So the whole thing here will become 1. So if the whole thing here become 1, you discover that s will stand alone, because s raised to power 1 is still s, equals to 3 raised to power 3 is 9. We have example 2, evaluate 4 under exponential function. Evaluate 4 raised to power s equals to 32, and then 27 raised to power s plus 2 equals to 9 raised to power 2x. 8 raised to power s minus 3 is equals to 32s plus 2 all over 4 raised to power minus x. So the first one, let's solve the first one. 4 raised to power s is equals to 32. 4 raised to power s is the same thing as 2 raised to power 2s. 2 raised to power 2 will give you 4. So 2 raised to power 2x will be equals to 2 raised to power 5 will give you 32. So therefore, the essence is to make sure that the base is the same. So 2 we cancel 2. You have 2s now to be equals to 5. 2s equals to 5 from their power. So 2s, which is equals to 5, by the time you divide both sides by the coefficient of x will be equals to 5 over 2. Alright, so now if this is the case, what you are going to have here now is this. You are going to have 27. Next example is 27 raised to power x plus 2 equals to 9 raised to power 2s. 27 is the same thing as 3 raised to power 3. 3 raised to power 3 will give you 27. So it's 3 raised to power 3 in bracket of the initial power, which is s plus 2. That is what we have here. Equals to 3 raised to power 2. 3 raised to power 2 will give you 9. So in bracket, multiplying that with the initial power, which is 2s, and that is what we have here. So therefore, what you are going to have now is the base are the same. So 3 will cancel 3. We have the power equals to themselves. 3 into x plus 2, close bracket, equals to 2 into 2x. So 3 times, open this bracket, 3 times x is 3s plus 3 times 2 is 6 equals to 2 times 2s is 4s. Collect the like terms. By the time you collect the like terms, you discover that what you are going to have is 6 is here already, equals to 4s. Then when 3s is going to the right hand side to meet 4s, change to minus 3s. 6 is going to be equals to 4s minus 3s is going to be 1s. So therefore x is 6. Alright, the next one is 8 raised to power 3 minus 8 raised to power s minus 3 equals to 32 raised to power s plus 2 all over 4 minus 4 raised to power minus x. So 8 raised to power 8 here, 2 raised to power 3 will give us 8. So that's why we have, instead of writing 8, we have 2 raised to power 3. Or of course, the power will multiply all the initial power here, s minus 3. S minus 3 is what we have here. So this is going to be equals to 2 raised to power what will give you 32. 2 raised to power 5 will give us 32. So therefore, the 5 will multiply by the initial power, which is what we have here. Then 2 raised to power 2, what will give you 4. 2 raised to power 2 will give you 4. Multiply by the initial power, which is minus x, which is what we have here. So now, you discover that the bases are the same. So let's express them further. All that we have here is what we bring down here, equals to the division. According to division law, you can pick one of these base, which is what we pick here, and subtract their power. The power is 5 into s plus 2 is what we have here, close bracket, minus 2 into s minus 2 into minus s, and that's what you have here. So that is division law. Then the base are the same, they are equal to themselves, so you can cancel it out. If you cancel this out, cancel this, you are left, the power can equate themselves. So the power of this one is what we have here. The power of the right hand side here is what we brought down here. So therefore, we open this bracket, 3 times s is 3s, 3 times minus 3 is minus 9, equals to 5 times s is 5s, plus 5 times 2 is 10. Then minus 2 times minus s is plus 2s. So here, before we collect the like things, 3s minus 9 is what we brought down here. Then here, 2s and 5s can be added together to give us 7s. Then plus this 10 is what we bring down here. So you collect the like terms. By the time you collect your like terms, you discover that, minus 9 is what we brought down here on the left hand side. Then 10 has no s, so we take it to the left hand side. If it's going to the left hand side, it changes to minus 10. Then 7s is already at the right hand side. Plus 3 here, 3s here. If it's going to the right hand side to mean 7, it changes to minus 3s. So minus 9 minus 10 is minus 19, equals to 7x minus 3x. 7x minus 3s is going to give us what? Okay. 7s minus 3s is expected to give us 4. It's expected to give us 4s. So this is another little mistake again, which I want you to override it. So here is supposed to be 4x. 4x. So by the time you divide both sides by the coefficient of s, which is 4, remember here is this 10 is 4. Treat this 10 as 4. Treat this 10 as 4. Alright? Okay, so what you are going to have is, therefore, s is going to be this minus 19 divided by the coefficient of this 10, which is 4. It's actually 4. It's not over 10, it's over 4. All right, thank you for your understanding. These things are handwritten, and these are little mistakes and challenges. We look forward to serve you better. Thank you very much. Then example 3, solve 25x minus 5x minus 20 equals to 0. Then b is all of this. Okay, so now when we have this, the first one here is 25 raised to power x, and then 5 raised to power s, then minus 20 equals to 0. If you look at this example carefully, you will agree with me that this thing is taking a shape of quadratic equation. Now, 25 is the same thing as 5 5 raised to power of 2. Okay, so 5 raised to power 2 will give us 25. So that is why we have this 2 here. Then minus 5s is here already. Then minus 20 equals to 0. Now, this turns to quadratic equation. Let 5 raised to power s equals to p. So wherever we see 5 raised to power s, we represent it as p. So this will be p raised to power 2 minus p minus 20 equals to 0. So by factorization method, if you factorize this now, you discover that you are going to have p minus 5 plus p plus 4. That is factorization method. Okay, you can look it up to know how factorization is done in any of my video. Alright, so now therefore p minus 5 is 0 or p plus 4 is equals to 0. Then p minus 5, if it is equals to 0, then p will be equals to 5. Because if this minus 5 is going to the right hand side, change to plus 5. Or p is going to be equals to minus 4, because plus 4, when it's going to the right hand side, change to minus 4. So therefore, remember we say this p should be 5 raised to power s before. So if p, that is 5 raised to power s, is now 5, therefore 5 raised to power s is equals to 5. So therefore the base are the same. You discover that the power here of this 5 is 1. So if the base cancel themselves, x will be equals to 1. Or here, you discover that if you say p is minus 4, so minus 4, you discover that this and p is from the initial, p is 5 raised to power s. So 5 raised to power s is going to be minus 4. Here 5 raised to power s equals to minus 4 is not valid solution, because from here you cannot find the unknown, which is x. Second example, another example again, 3 raised to power 2s plus 1 plus 3 raised to power x plus 2 equals to 12. Okay, so what you have here, you discover that from product law, something happened here. From this thing is merged. According to product law, you can split them. This thing is gotten from 3 raised to power 2s times 3. You pick one of the base. If you are solving back to the question, you pick one of the base, which is 3, multiply the power, add the power, 2s plus the coefficient of this 3 is 1. So that is how they get here, and from here we're able to get here. Plus here too, we are going to split it, 3 raised to power s times 3 raised to power 2 according to product law, which is equals to, this is before then, this plus 12, if it's going to the left hand side, is minus 12 equals to 0. The whole idea is that the whole thing is turning it into quadratic equation. So therefore, if you look at this place very well, you discover that you have 3 raised to power s in bracket of 2. This side, we re-express it again, because 2 times x will still give us this 2s. So times 3 plus 3s times 3 here raised to power 2 is 9. So minus 12 equals to 0. So we can now say let 3 raised to power s equals to k. If it's equals to k, discover that here 3 raised to power s will be k. Alright, and if here is k now, it will be k squared. That's how we have this k squared. This 3 is this 3 here. 3 times everything here will be now 3 times k squared. Plus here will be k. So 9 times this place, which is 9 times k, will be 9k minus our 12 equals to 0. Alright, so therefore all of this thing is still equivalent to k squared plus 3k minus 4 equals to 0. What we did here is we reduce this quadratic equation by 3. Divide here by 3, divide each of the term by 3. 3 will cancel here, you are left with k. If 3 go into this 9, reduce it to 3, divide it, it will be 3. 12 divided by 3 will still be minus 4. 0 divided by 3 will still be 0. Alright, so if you factorize this, you discover that it's going to be factorized into k minus 1 and k plus 4 equals to 0. So therefore, k minus 1 is equals to 0 or k plus 4 is equals to 0. Then if you take this minus 1 to the other side, to the right hand side, it's going to be plus 1. and if you take this plus 4 to the other side, it's going to be minus 4. So this minus 4 is not valid. It's not valid. So therefore, if 3 raised to power of x is k, we say is let it be k. So in place of k, we write 3 raised to power s, which is going to be 1 equals to this 1. So therefore, is the same thing as 3 raised to power s equals to, how do we get back this 1? We want to make the base to be the same thing as 3 raised to power 0. 3 raised to power 0 is still 1. Still 1. So the base cancel the base. So x is equals to 0. So our unknown is 0. Alright, so thank you. Don't forget to share, and then don't forget to always keep in contact. You can get this note on Telegram. Always check Telegram for your note. You can reach out to me in my WhatsApp contact. It's always attached there to my videos. Thank you.